Hello friends, this is Gus from 3dplanner.com, and in this video I'm going to give you a quick update on what has been happening with the IKRig implementation I provide through GitHub. So the IKRig is a thing proposed by Alexander Brezniak, and I have talked about it in a previous video and also in this blog post. So I really recommend you look through those materials if you don't know what the IKRig is. Now, I created a implementation of the IKRig in Maya because I really think it is useful not only for motion retargeting, but also to represent poses for machine learning models, and that's really my real goal here. So, what has been changed since the last updates? So, the most important thing that has changed is how I represent the offsets of each of the limbs to their base. So for example, the legs base is the hips, so we need to know the offsets from those, and the arms base is the chest, so we need to know the offset from those. And this would be represented before with a normalized position. So that was great if we had the same skeleton layout, but with different character proportions. So for example, here I have a skeleton from the CMU dataset, and I can use the IKRig to retarget this motion to any other skeleton in the same dataset, and it's going to work just fine. But you can see that this skeleton has quite a different layout from this one. So for example, here the hips, they're up higher, and the beginning of the legs is a bit down low in what looks like an A shape. And in the mannequin from the Unreal Engine, we see it's more like a upside down T shape. So whenever we try to use the IKRig to transfer the motion from this rig to this rig, it would do something like this. It would bring the root of the legs down. So that's not what we want. So what I did to change this was to, instead of represent this as a position, I represent it now as an orientation. So this fixes the problem. The only thing we now need to add is we need to know what's the distance of this guy, like a T-pose, or yeah, at a T-pose, and then we can use that to offset with a rotation. So let me show you the before and after. So I'll load the old IKRig and show you a sample scene. So this is what it looks like. It compensates those positional offsets, and it really looks bad. The legs are lower, the arms are a bit higher. You can see the neck is way down because right here the neck starts at the chest, and right here the neck, right now you can see it, but the neck would start up, and then, you know, because we're doing this with the offset positions, it brings the neck down. So if we try to open that same scene now with the new IKRig, works. Oh, it doesn't work because I forgot to load this one. Okay, unload the old one and load the new one. And now it should work just fine. Great. You can see the legs and the arms look a bit funny because the limbs here, they are stretched 100%, so there is no orientation. But if you go to frame 1, you can see everything is working correctly. Okay, so that's the first change. And I also added some utilities to the repo. So the first utility is also an add-on that you can load right here. It's called utils, and the only thing it has is a CSV reader, which should be right here. Okay, it's not right here for some reason. Okay, let me bring it up. And what this does is you can load a file with a previously stored animation in the IKRig format. I like this one. And we can connect the time right here, so we have a frame. And then we can load that to the rig. And now we can store animations in the IKRig format and then read them for later use. We also use that to export animations and bring animations back when you're training machine learning models. Let me just hide this one and give us a little bit more frames right here. You can see it works nicely. Okay, so finally, the last utilities that have been implemented are these helper functions. And there are a few of them. There is the printed name values that shows you each of the dimensions of the encoding vector and what they represent. And also I have a wiring function, so you can wire a IKRig encode node in a wire function for an IKRig decode node. So you only need to give it a name mapping and it will do all the rest for you. Okay, so there was one more thing, which is now you can also tell let me go back to this guy right here. So now I'm back to streaming the data from this rig that's on my scene. Okay. And let me just show you something that I didn't have before, which is this normalized global exfo option. Before I would always normalize the global exfo, but I realized in some cases that may or may not be something you want. So right here we're encoding it with a normalized global exfo, and then we're decoding with normalized global exfo. That means that if our character is larger, his steps will be also greater, and it will move forward or backwards in a larger percentage. So for example, if I make the character higher, so let's say from 96 height to a 120 height, since this normalized global exfo is on, he should actually go back further to the scene. Okay, so he should go further away from the origin. Let me just show you that. So I grab this and I change this. You see it will go farther or closer to the origin depending on the height. Okay, so this is just like a compensation. And let me go back. Now, if we turn that off, let's this, and then we turn this option off. Now the character will be exactly on the same position as the other one, because we're not doing anything to the pose, not doing any normalization whatsoever. So you say, what? But it is not exactly on the same position. That's because we have an offset. Since if we make that offset 0, and it's also not in the same position because I made it larger. So let me just go back here to 96, and now we should be exactly on the same position. Okay, so This is really useful. I encourage you to always keep this normalized, but maybe you want to get the character speed and something like that, and maybe you don't want to normalize it. That's okay. And well, I guess that covers most of the things that have changed since the last release. Now, on to more interesting news. There is no reason that this cannot be implemented elsewhere, in places like 3ds Max and Unity, Unreal Engine, and so on. And I think it would be quite useful to do so. So I tried to do a implementation of this in the Unreal Engine, and it works quite nice. So right here you can see an example. Right here we're loading that same first animation that I showed you, which is from the CMU dataset, and we're using that same mannequin, and we're loading a CSV file, reading it, and then transposing it to the mannequin using the IKRig. Let me show you how that is done. Let me just show you that we're really doing this live. I can load a different CSV file. Like right here, I can go and change the file, and the animation should be different. And there we go. Now we have a different animation. Okay, so what's going on here? I have only implemented two things, really. A CSV reader that will take in a time and read that CSV and output the line that has the IKRig vector that we want. And then there is an IKRig decoder object that we can use to create the position of the root of the limbs and the direction of the limbs and the effector position and orientation. So I create a blueprint, a animation blueprint, and first thing I'll do is create the CSV object, and I'll create the IKRig decoder object. I also create a time variable, so we can count the time and load the animation. And I'll initiate the CSV reader with the file and the frame rate, and I'll initiate the IKRig decoder with the properties of the skeleton that I want to output to. Since the IKRig encoding itself, it's normalized, so I don't need to give it the input rig size, but I need to give it the output rig size so it works correctly. And then at every tick, at every animation update, I will count the time, make it higher, and then I will read the CSV, get a line from it. This line has 86 dimensions, which are the dimensions that describe the IKRig pose. And then I'll decode this and get the limb root positions. I'll store each one of them in a variable. Then I'll get the limb directions. And here I'm just doing that for the arms and legs, because the spine and the neck are solved with a fabric solver and don't need those. And then I get the position and orientation in the form of a transform for all the limb ends. So the chest, the head, and also I get the transform for the global axle. And then if I go to the anim graph, what I'm doing is just like a basic IK setup in Unreal. It's the same. If you go to the demo scene examples and you go to the animation examples, you see it's pretty much the same. So I transform the position of the hips. Then I use a fabric solver to solve the IK of the hips. Then a fabric solver to solve the IK of the neck. Then a 2 IK bone to solve everything else. So the legs, the arms, and then I load all those variables that I have set in the event graph. And finally, I will set up the global position and orientation, and then I'll make that the final pose. So you can see it's pretty standard. Of course, it's not going to work well with all the animation pipelines that are already established in Unreal. It's more like a proof of concept, but it really works. So it's nice. You could have different characters right here of like different skeletons, and then you would adjust something like this, like make it taller. And now it's, of course, now I'm not making the legs longer, so he'll fly, but you get the point. I could make the spine smaller, so it make it look funny, like this, or make the spine bigger. And it would look funny like that. Okay, so proof of concept, nothing amazing, but it's fun to see it. It's in action. I'll make it also available, the code for both of these guys in the repo, and then I probably won't make this project available because the size of the project is really big, but let's see, I'll try. Okay, thanks very much for watching this video. If you like what we're doing, please subscribe and share. Thank you.